Hello and welcome, ladies and gentlemen, for this second part of my video about the CLI find. So last time we were looking at some test expressions, which are filters of our search. This time we will look at action expressions, where you can do something, an action, with the result of the search made with find. So as always, the link for the files are in the description. You can follow along with me and test a bit in your terminal what we are doing. I will ask you at the end of the video some questions as well. You can try to answer them, and even if you have no idea, it will help you remember what we will see together here. So let's begin. So the first interesting action is the delete action. What you can do, for example, if I want to find something which is called hidden, which is one of the file, and then I want to delete it. And here we go, there is no .hidden file anymore. I will recreate it. So basically, it deletes everything which is find by find. So let's add delete to our expressions here. Here we go. Now a more complicated expression is the exec command. With that, you can perform any command on the result of the search. So for example, if I want to display the base names of every file, I can do that. So first, let's display every files and directory from our current directory with the starting point, the working directory. So I can do that, and then I have every files and directory from my starting point. Now, if I want to display only the base names of those file paths, which means only the name of the directory or the file, I can do that. Oops. And here, as you can see, I don't have the path anymore, but just the base name, because every single path was given as input to base name, which is a CLI. And for example, if you do that, we'll just output the base name of your file path. So everything found by find will be then passed to the input of base name, and it will output the result of that. So here there is two things to understand. First of all, those two curly brackets here, those one, represent the name of each result of find. So, for example, the first result of find is dot, and then base name dot will be run. Then it will be dot slash symlink, and then base name dot slash symlink will run. And so on and so forth for every result of find, and then the output will be the output of base name in that case. So those two curly brackets represent dot slash symlink or dot slash dot hidden every single result of find. The last element, this one, the semicolon, means that it's over for the set of expression. You could add more expression afterwards if you want to do other stuff, but it's rarely used. But the syntax oblige you to use this semicolon anyway, even if you don't have anything afterwards. In how it works. So I already did a video where I use minus exec as expression with FZF. So I encourage you to watch this one to see a practical case where you can use the expression exec. So like exec, you can use exec dir as well, which is a bit different. So if I do that, it's a bit different. Yeah, more like that. It's a bit different because exec dir we run as if you were in the starting point, even if you're not. So what does it mean? If I give a starting point document, and I will use echo more, you can see that it's as if I was in the folder document, in the directory document, and not in the directory find. My working directory is fine, but it's not document, but still my output is ./documents like I would be in document. If I use exec instead, here in the current directory, the working directory is the directory find, and it's not the directory document. So it's really a question of perspective and how you want to run your command and what command you want to run. So it can be useful sometimes when you need to be in the your working directory to be the starting point of your command. Finally, in the same for the same idea, you have the command OK, which is like exec, except that it will prompt you each time for each result given by find if you want to run the command you precise. So if I run that, it will ask me, do you want to echo the /dot? Yes. Do you want to echo the /symlink? Yes. You want to echo hidden? Yes. And so on and so forth. You can answer no as well, and then nothing is echoed. Now, it's not really useful for echo, but if you want to do RM, for example, to delete some files or even directory, so you can do that, and here I will say no each time, but if I say yes, it will delete the directory or the file. So let's add all of that here. Okay, dir. Exec dir, and OK. And you have the OK dir as well, which is like exec dir, except that you have a prompt each time. But your working directory will be your starting point. So these action expressions are super useful and super powerful, as you can imagine, because you can basically run every single command you want on every files and directories of a file system, recursively, in one line, which is really cool. Other action expression which can be useful, or the action expression which can modify the output of find itself. For example, if I do find dot -ls, it will display many more information for every files and directory output. Something I didn't explain, but when you do find dot, or just find documents, in short, when you don't use any expression, by default, there is still an expression which you use, and it's -print. And if you don't precise it, or if you precise it, it's the same. It will just print everything. And as you can see here, print will output the results with a new line as a separator. If you do -print 0, you can see that there is no separators between the different results anymore. At least it seems like that, but it's not true. there is a separator, and it's the ASCII character null. And the ASCII character nulls, when you display it, it's null, nothing. Now you might wonder, why is it useful? It's a bit messy. It's useful actually when you use something like xargs. So xargs, what it can do is taking the output of a command and use it as argument to another command. On a Linux or Unix-based system, there is two things. There is an input, and some commands take an input, and some other commands take arguments, and both are different. And for example, echo take an argument, but cat take an input or a file. So what's the difference when you do echo and then you hit enter? There is nothing happening. But if you do cat, then it will still expect an input. So you can do hello, and it will cat hello. And you can go out of the input by doing CTRL+d. So that's how you know that a command takes an input or an argument. And the thing is, if the command doesn't take an input, you can't really pipe it. If you do cat readme to echo, it won't work because echo doesn't take an input. It takes an argument. But if you use xargs, it will work because xargs will take the output of cat and use it as an argument. And now it echo the whole file. So I hope it's clear. And coming back to our -print0, it's useful because let's say you want to use xargs and you want to use a word count on every files here, and word count take as well arguments. So if you do that with print, it works, or you don't even have to precise print actually, as we saw. It works. I mean, it doesn't work because we have directories as well, and wc word count doesn't take directories as arguments. So let's get only the files. Here it works. You have the count of line in that case for each files, and you have even a total at the end. That's great. But the problem is if you have, let's say, a file which has spaces, like that. So we have a file with a space in the middle, and xargs by default will know that the output given to xargs, so the output of find, xargs will consider every argument separated by a space, which means that for xargs, the file a file is at the end two files, the file a and the file, which is not true. So if you do that, you will have an error somewhere because a is not a file and file is not a file. So instead of separating the different arguments given as input to xargs, which is the output of find, with space separations, you can say, hey, I want the ASCII null character as separator. So for that, you do xargs -0. But you need, on the other side, that find output every files, but with the ASCII null character as separator. So for that, you do print0. And this time, everything is working. And even for the file a file with a space in the middle, it works as well because we don't have the space as separator anymore. So that's great. We can delete a file. And here we go. So print and print0 and ls are pretty cool. And print0 is mostly used with xargs, but not only. I mean, many CLI can output their results with the ASCII null character like grep, I think, and sed as well. And then you can pass that to xargs and be sure that nothing will crash. Because most of the time you don't really know how the files are really named, and it's more secure at the end. Okay, another expression which can be super nice as well is printf. And if you did if you wrote some programming languages which are based on the C programming language, I'm sure you bumped into printf. It's the same here. So basically, it will output whatever you want to output, given the different argument you can give. So for example, if I do printf %p and then a new line, it will print basically the name of the file. I mean the path of the different files and directory. If I do uppercase P, it will only display the relative file path, so without the dot at the beginning. And to be more clear, if I do a find on documents, it will again display only the relative path and not the absolute one. You can display other stuff, like for example, M is different permissions. I think D is the depth of the directory tree. Yeah, that's it. So if you do that, document readme is the second depth of the directory tree because it's in the folder document, for example. You can look at the manual page. There are a lot of other formats you can use. And that's pretty cool if you want to display only what you want. All right, so let's just add fprint here. No, sorry, printf. And you can use this for expression with an f at the beginning. And instead of output, the output in the terminal, in the shell, it will output it into a file. So you need an argument for each of them. So for example, if I do -fls my file, it won't output anything, but if I look at the content of my file, it will output, the search results with all your expressions. So it's pretty cool. I mean, of course, you can always redirect the output to a file directly, but I mean, you can use that as well. All right, last one is quit, which is, I mean, not that useful most of the time, but it can be useful, for example, if you want to display only one thing. So for example, if I do find and I want only the log files as output, I can do that. But now I just want the first output and not the second, so I just want to output logs pacman.log. I can add the expression quit afterwards, and automatically find will just run the name expression, find the first result, and then normally it will iterate and then find the second log. But with quit, it won't iterate, it will just quit. And it doesn't work because I need to print it before. That's a little a little thing to know is by default the print happens at the end, so you need to do it before the quit. Alright, that's all for the action expression. We can now look at operators. There are global operators as well, but here I'm speaking about local operators. The global one are, I mean, there are few and they are not that useful. So local operators are a bit better. You can think of them as logical expressions like AND or negation, stuff you can use in different programming languages for conditionals, or you can use in propositional logic as well. For example, if you want to find the file hidden, you can do that. If you want to find everything but the file hidden, you can negate it, like that. So you add a bank before the expression you want to negate. I encourage you to use a single quote because otherwise your shell can interpret the bang as something else. So here we go. And now we have every single files and directories except the file which is named hidden. By default, when you do two expressions, like for example, I want a file named hidden, and I want it to be a regular file. Set file its type. Well, it works, but what we don't see is there is an end between. You can write it like that or like that. It does exactly the same thing, which means that I want a file named hidden or end, and I want the type to be file. So both expressions, test expressions in that case, need to be true. If you do or, and if I want something which is named documents or a type file, it will basically output everything, because I have some stuff which are named document, and I have others which are of type file. As you can see, the directory logs is not displayed because it's neither something which is called documents or something which has the type file. It's a directory. It would work if you do something like that, and then you would have the logs directory this time. And I think the last very useful, in some cases, local operator, is the comma. So for example, let's say you want to find every log files, and you want to write the result into the file log files. And if you want all MD files and you want to write the result into the file MD files, you can do that. Name, and then this, oops, forgot that. So I print the result into log file, print the result into MD file, and it will work. If I look at log file, I have my result. If I have MD file, I have my result. Now, if I didn't add this comma, it wouldn't work because it would try to find something which has a name which finished by .log, and then printing into log file, and then something which has a name, and then printing into MD file, which is weird, and it won't work, because if you look at log file, it will work, but then when it arrives to name MD, name, star.md, it won't print it into MD file because there is no file which has the name at the same time which finished by log and which finished by MD. So there is a problem here. The comma allow you to have just set of expression which go together. I mean, I think it would work if you would put a or here, and then you can put as well parentheses if you want to play on the precedence, so on the priority of of the expression read. If I do that, if you do that, I think it will work. Yep. So it's a bit equivalent, but I prefer using a comma in that case. So it's practical as well if you have a different set of expression you want to run together. All right, let's do some exercises now. First exercise, can you find every directory from the working directory and write them into the file dirs? So you can pause the video if you want and try to answer the question. And here's the answer. So we want to find every directory from the working directory. So you can do find dot, or you can just skip the dot because by default it will be always a working directory. I like to put the dot because I think it's more clear like that, and it just gives you the intention of what you're trying to do. We only want directories, and we want to write print them into the file dirs. And if we do that, indeed we print every directory into dirs. If we want to skip the dot directory, for example, we could do that. I don't want the directory named dot. And it doesn't work because I think the action should be last. Yep. So yeah, another thing, if you have test expression and action expression, put the action last because otherwise it will be print before the test, and so it will print everything into the dir, into the file dirs, and then it will verify if there is a directory which has the name dot, which is not what we want. Okay, second exercise. Find every file with extension .log and create prompts to delete this file. But don't delete any at the end. What we want is just, hey, do you want to delete this log? And do you want to delete that log? And just answer no each time, because otherwise you will delete everything. So here's the answer. We want to find every log, so we can do, we want to find every file which are named something.log. And then we want to create prompts with the expression OK. And we want to delete this file. Oops. So something like that. And I don't want to delete pacman.log, and I don't want to delete ASCII.log. Here we go. All right, last exercise. Can you rename every regular files using find, adding back as an extension for every file? So you can do that, find everything from the working directory, only regular files, so we need the type file this time. And then we need to rename everything, so we can use exec with mv, and we want to rename the file into file.back, and at the end the semicolon. If we do that, every single files have been renamed with .back, and we can see even better here. So that's it, and that's pretty cool to rename everything you want. So that's all for today. Thanks a lot for watching, as always, for pleasing the YouTube algorithm, which will save us all. You can hit subscribe, hit the like button, hit every button you want except the dislike button, because it would make me very sad. And yeah, thanks a lot for watching. Please let some comment if you want to see some improvements in my video. I love receiving feedback. It helps me deliver even better content. Have a very, very nice day and see you next time.